Hello. Hello, a couple people still coming in. Let me get them all in. Good morning or afternoon. Hope y'all are doing well today. So again, just a reminder to keep your mute on whilst we're lecturing. Great, so we will just sort of continue lecturing where we left off last time. I did end up figuring out how to get on YouTube and put the video up there. So I've got to insert the link into your Moodle page, but I should be able to do that sometime today, possibly, or tomorrow. So if there's anything that you missed from the first lecture, you can go back and rewatch it, and then I'll end up posting this one on there too. So if you're like, I understood what she was saying during class, and now that I'm doing homework, I don't get it, you can rewatch me teaching you the information, okay? So let's go ahead and share our screen. Great. Hello, Erica, let's let you in. Nick Taylor. Sorry, I did yoga like right before this, so I am super, super zenned out. One of the nice things about being able to work from home. So it will be a relaxing chemistry class. Everybody take a deep breath. All right. So there were a couple things I wanted to go over from the chapter 1. There's a lot of stuff in there that were like, I'm not going to go over, but I still want you to look at, but some of the calculations towards the end, I do want to talk about. Just want this to go on the side, but it's just never going to do that. I could figure that out. All right, so not 092. Sit here. Close you guys up for a little bit. All right, so we had talked about isolating variables last time. Yeah, okay. Okay, calculator operations. This is sort of no-brainer, but multiplication, division, addition, subtraction, negative, if we need to make a negative, negative or positive. Every calculator is going to look a little bit different, but you definitely want to familiarize yourself with those. There may be a point in the semester where we use the log button, which is the opposite of an exponent base 10. So when I say like 10 to the third power, if I wanted to undo the 10 to the part, I would do the log. That would be the opposite operation. But again, it's just going to be a function you plug into your calculator. So nothing to be too intimidated. So I know sometimes people get a little freaked out. They're like, oh my gosh, math, didn't sign up for math. We're not going to be doing too crazy functions, but we will be using those functions, multiplication, division, addition, subtraction, a lot. Okay, so I trust you guys know multiplication stuff. One thing that I want to talk about is calculating a percentage, just really quickly. So yeah. I'm gonna have to log out. That's fine. Yeah, if you guys ever have issues where you got to log out and log back in, don't worry about it. You don't even have to tell me. Or if you have to leave a little early, don't worry about throwing it in the chat, because I'm not really keeping track of every single person that's in here anyway. So you can just kind of move freely. Just make sure when you come back in, you're muted up. Okay. So a percentage, if you look in the word percentage, you can see right here, C-E-N-T, cent. A century, a centurion, All these things are in reference to 100, right? A cent or a penny is 1/100th of a dollar. So when we're calculating a percentage, we're calculating a ratio of parts to a whole in relationship to 100, okay? So let's say I have 8 chemistry books sitting in my office, and but I have a total of 32 books. So I've got some other books, I've got some yoga books, I've got some self-help books, I've got some geology books, I've got some random things, art books, right? 8 of them are chemistry books. So if I want to figure out what the percentage of my total books are that are chemistry books, I'm going to take 8 divided by 32, and you're going to get something like 0.25. And so what you're going to want to do is multiply that by 100 to get it into a percentage, or how many per 100. So when we multiply that value by 100, we end up getting 25%, which is similar to saying that, hey, if I had 100 books at the same ratio as my office, 25 of those books would be chemistry books. Okay, so we are going to be doing a lot of calculating percentages throughout the semester. Here's another way if we gotta go in the reverse direction. So let's say we have 5% red balls. That would mean that for every 100 balls, 5 of them are red, right? So 5 divided by 100 gives us that 0.05, and then we multiply it by 100 to get it into a percentage. Cool. We'll just leave it at that. If you want to do practice on it with me in Office Space or something like that, feel free to come find me. Okay, we isolated variables. We're not intercepting a graph. All right, did we, just someone throw in the notes, did we start scientific notation? I think that's a big no, but all of my classes start so similar that I get confused. So if someone can say yes or no, that would be helpful. I got one. No. Okay, cool. All right, I am good with the no's. Thank you, ladies and gentlemen. So in chemistry, we are going to be dealing with a lot of, where can you go? Go away. We're going to be dealing with a lot of really, really big numbers and really, really small numbers. So in this image here, people have an average of 1 × 10⁵ hairs. So we have a lot of hairs, right? We're not going to sit around and count hairs all day because we would be here all day. Still not good at isolating variables. Okay, Hannah, come find me after class or during a lab time office hour, and we can totally play around with that. So we're not going to count all the hairs because it's going to take forever because it's a really, really big number. So also, when we're writing really, really big numbers, they can get sort of cumbersome because they can have like all these zeros. So what we can do sometimes is write these numbers in scientific notation. Scientific notation is composed of 2 parts. So there's a first part, which is some sort of number / decimal number. And that number needs to be between 1 and 9.99999. Okay, if it was 10, we would drop it back down to 1 and move the decimal over again. So first part is between 1 and 10. Second part is an exponent, so it's always going to be a base 10. So it's going to be times 10 to the some sort of exponent. The exponent is that little guy in the upper right-hand corner. If the exponent is a positive number, like we have, for instance, in this first one here, that means it's a really big number. Okay, so just conceptually get in your mind, positive numbers mean big number. On the other hand, I believe this is asking or shows us the width of each hair. We're going to go with that's a really tiny number, right? And we can see here it's 8 × 10⁻⁶ meter. So again, we have in a decimal here, which is 8. Sometimes when you get a little more precise with your numbers, they would say something like 8.0 or 8.1, something like that. Times 10⁻⁶. Now, the difference between this number and this number, obviously, besides the numbers that they've inserted, is that this has a positive exponent. This thing here has a negative exponent. So if you're seeing a negative exponent in that upper right-hand corner, that means teeny, tiny, tiny number, all right? Some teachers will teach it, oh, well, if it's a positive number, you're going to be moving to the right. If it's a negative number, you're going to be moving to the left. I don't remember, right? And I still have trouble, like I have to look at my hand and think, okay, that's my left hand, that's my right hand. So I don't teach it that way. I teach it conceptually. Positive is going to be big, negative is going to be small. All right. So kind of already went over this, but the first part of your number written in scientific notation is your decimal, or sometimes they use the word coefficient. And then there's going to be a second part, which is a power of 10. So let's look at 2,400 here. Now, this is a number that I wouldn't traditionally write in scientific notation because how many characters are here? 1, 2, 3, 4 characters. How many characters are here? 1, 2, 3, 4, 5, 6, 7. It's more cumbersome to write it in scientific notation, okay? But for the sake of just teaching you how to do it, this is the number we're working with. So we take 2,400. The first thing we want to do is write the coefficient. The coefficient, or the decimal, needs to be between 1 and 10. So when looking at this number here, the decimal lives right here. If you don't know that, there's an inferred decimal right there, okay? We're going to move the decimal to get the number to be between 1 and 10. So in this case, I'm going to put the decimal, bam, right there between the 2 and the 4. So our new number becomes 2.4. Why don't I put it here? Because 0.24 does not fall between 1 and 10, okay? Why don't I put it here? Because 24 does not fall between 1 and 10. So you want to make sure you get it between 1 and 10. So we've got 2.4. Now, you can't just take 2,400 and reduce it to 2.4 and then just leave it at that. Because what we've got going on is two totally different magnitude numbers, right? This is a big number. This is a relatively small number, 2.4. So we need to preserve the size of this number. How do we preserve the size? That's where we add our exponent. So the power is always good. The power of 10 will always be your base. And then we need to add a value to it. So is this a small or a big number? Ask yourself that. And we're going to say that's a big number. So our exponent should be positive. Okay, so make sure you've got a positive exponent. And then how do we know what the value is? Well, it's how many hops it takes you to get to that decimal. So our decimal originally lived here. It moves to here. So I have to take 1, 2, 3 hops. So 2.4 times 10 to the 3. Meaning that if I was to expand this back out, I would hop it 3 out to make a big number and I'd end up with the original one. Okay? So let's do a little bit of practice on that. Let's see if they've got some other examples here. Yeah, so here's another example. So we did this first one here. We have this number 0.00086. This is a teeny tiny number. So I know that my exponent is going to be negative for this guy. So I need to move my decimal until I hit a place where I'm between 1 and 10. So in this case, it's 8.6. And then am I making my big number small or am I making a small number big? I'm making this small number look much bigger than it actually is. So I have to preserve the teeniness of it. The way I do that is putting the exponent in. So I go times 10 to the, and I figure out, sorry guys, figure out how many hops it took. So decimal is living here. In order to get between 1 and 10, I have to go 1, 2, 3, and 4. So 8.6 times 10 to the -4, negative being we're dealing with a small number. So just so you know, when you see something like 1 times 10 to the 4, that's saying 10 times 10 times 10 times 10. So there are, when we plug this number in, it will have 4 zeros, hence why we do 4 hops. Okay. 1 times 10 to the 3 will have 3 hops. 1 times 10 to the 2 will have 2 hops. 1 times 10 to the 1 is just 1 hop. And 1 times 10 to the 1 is also 1 times just the value of 10. 1 times 10 to the 0 means no hops. Okay, so we wouldn't take any hops. It's not a multiplier of 10. We look at some of the inverse or the negative exponents. Instead of taking it 1 times 10, we would do 1 divided by 10. Okay. When we have 1 times 10 to the negative 2, it's 1 divided by 10 times 1 divided by 10. Continuing on, where the zeros will accumulate underneath the decimal bar. So here is the diameter of the chickenpox virus. It says that it's 0.00000003 meters. So conceptually, you're thinking, that's small. that's all I can go with, right? Because it's a meter and it's just a very small amount of a meter. So what we can do instead is write it in scientific notation to maybe apply a little bit more value to it. So I'm going to hop this decimal over until I get between 1 and 10. So it goes 1, 2, 3, 4, 5, 6, 7. So 3 for the coefficient, 7 hops. And is this a big or a small number? It's a small number, so we throw that negative in the front. Internet cut out, no worries. Okay. So here are some numbers written in scientific notation. Volume of gasoline, oh, this is depressing. Volume of gasoline used in the United States each year, okay? So we've got, what, 550 billion liters of gasoline are used each year. That, again, can be kind of cumbersome to write. So instead, we're going to write it as 5.5 times 10 to the 11th liters. Again, we'd hop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Looking at this number down here, so mass of a bacteria is very teeny tiny amount of the kilogram. This is a total pain in the butt to write, much easier to say 1 times 10 to the negative 19. Okay. When looking at your calculator, super choppy. Maybe try a different spot in your house if you're having trouble with the internet. So exponents, as far as in your calculator are concerned, there's a couple different ways you can plug it in. One way you can plug it in is, let's say we're doing 4 times 10 to the 6th. So if you have your calculator available, you may want to try this or search for it. So one way you can plug it in is type in the number 4, type in the multiply symbol, type in 10, then type in the little caret or the little exponent, and then 6. Okay. That should pop out a number where you have 4 with 6 zeros. Okay. Somebody's mic is on because I can hear you unzipping the bag. So just turn your mic off. That can sort of be a pain to plug it into your calculator that way. So if you have a scientific calculator, this value or right here is really useful, or this button right here. It's usually symbolized as either an EE or an EXP. If you don't have it on the direct button, look at your secondary functions, which sit above the button. Sometimes they're in blue. And what you might have to do is click second and then that button, okay? What the EE button or the exponent button is going to do is that's going to capture the times and the 10 and the little caret. So it's a much faster way. So you would type in 4, EE or exponent, 6. And that should also give you a number of 4 with 6 zeros after it. Now, this is sort of where, you know, if your calculator is not great or doesn't have an exponent button, it can start to get to be a little bit of a pain plugging these things in, especially if I've got a number that has an exponent and another number that has an exponent. And let's say the other number has a negative exponent to it. That can get sort of blech, gross. Your cell phone calculator will have, let's see, pull mine up. So I've got this function. You can get a better calculator, but if you turn your calculator this way, it expands it on an iPhone, and it does have an EE button right there, okay? So if you're using your phone, which you really shouldn't be using your phone for your calculator, but yeah, if you're using your phone for your calculator on exams and stuff, there is that option on your iPhone, okay? So here, all of these slides have these sort of step-by-step guides to how to solve these problems. So they may work for you, they may not. We'll go through them relatively quickly and then do some example problems. So this thing says, move the decimal point to obtain a coefficient between 1 and 10, which we already talked about. Express the number of places moved as a power of 10. Write the product of the coefficient multiplied by the power of 10. So let's look at these two numbers. I want you to go ahead and try and do these two on your own in scientific notation, all right? So first one, we're dealing with a larger number. Second one, we're dealing with a smaller number. So do the best you can to work through that. I have some tea waiting for me, so I will be back in just a moment. All right, so for this first one, we've got 6, 4, 0, 0, 0. The decimal is living right here. If you don't see the decimal, it's just at the end of the number. We've got to move this decimal to a place where we get a number between 1 and 10. So if I start, I'm not going to hop this way because that's just going to make the number bigger. So I'm going to start hopping this way. 1, 2, 3, 4. Sorry, the annotation button in Zoom is really hard to draw on. I'm doing the best I can here. All right, so we've got 6.4. 6.4 times 10, because we're always going to have that times 10. We're dealing in this situation with a really big number, a relatively big number. So my exponent should be positive, and the amount of positivity it has is however many hops we took. So we took 1, 2, 3, 4 hops. So I'm going to put a positive 4 there. This other guy, 0.021. I'm not going to hop this way because that's just going to make the number smaller. I need to get my number between 1 and 10. So 1, 2, stop there. 2.1 times 10 to the, and then what we need to do is add our exponent. 2 hops, and it's a small number, so it'll be a negative number, -2. So you just want to start getting in the habit of when you see negatives in that exponent, that means small number. When you're seeing positives, that means a larger number. And I want you to go away. Okay. So this is going to, redundant. It's just kind of going over everything we just did. Okay. So I want to give you guys a couple more examples for scientific notation, going in both directions. So having a number and writing it in scientific notation, and then also I want you to take a scientific notation number and write it in the opposite direction. Oh yeah, let's do Galaxy Pen, why not? We'll have a little fun here today. So, no, can't do Galaxy. That's too wild for me. That's too wild. We'll go with purple. 2, 2, 6, 0, 0, 0, 0, 0. Okay, so write that in scientific notation. I'm gonna have you write 0.00572 in scientific notation. And then point, no, I don't want to do point. And then 18 in scientific notation. So try those 3. Hannah, is your dog helping you do some chemistry? No, not helping at all. Sometimes I have my French bulldog in here with me, so if you ever hear snoring, that's what's going on. Those pesky dogs. Yeah, Beth Stewart, the VP of AB Tech, sent this like comedy video out about the after quarantine human and what they'll look like. And there was this guy going out into the world again with having to put like real clothes on and wash his hair. And he went into the office, and in order to make himself comfortable, he had like a blanket and a pillow, and then he had a recording of his dog on his phone barking. Like, yep, that's pretty much our life now. All right, let's do these. So I'm gonna change colors here. So decimal for this big guy is living right there. We want it to live there. So we're gonna hop 1, 2, 3, 4, 5, 6, 7, 2.26 times 10 to the 7th. You like that? You can give me a head, yeah, no, no clue. Yes. Okay. So next one here, small number, decimals here. We want it to live right there. So I need to hop 1, 2, 3, 4, 5.72 times 10 to the -4. Why is it negative? Teeny tiny number, all right? This guy here, I would never write this in scientific notation. It's a total pain in the butt to write in scientific notation, but we're gonna do it just for the sake of practicing it. So decimal lives here, we need it to live here, right? 1.8, that didn't work out. 1.8 times 10 to the 1. How many characters here? 2. How many here? 1, 2, 3, 4, 5, 6, 7. Yeah, totally pointless. for us to be writing that in scientific notation, but for the practice of it. So let's do a couple going the other direction, okay? Move this over here. So I'll give you the scientific notation. I need you to expand it out to the full number. 8.26 times 10 to the negative 3, 5.01 times 10 to the 7. And then I'll do one that's just a pain in the butt so that you want to start getting into scientific notation more. So let's do 9.4 times 10 to the negative 24. Yeah, you like that one, Courtney? The second equation and the first set of examples I type. On the second, okay, so Janine, on the second equation, on the first set of examples, after I typed 5.72 times 10 to the negative 4, it didn't equal to 0.00. It reflected the equation. Are you talking about in your calculator? Your calculator kept it as an exponent? Or I'm sorry, your calculator kept it as scientific notation. Yeah, sometimes the calculator will do that. It won't expand it out for you. It wants to keep it preserved in scientific notation. So just start to get comfortable with when you see 5.72 times 10 to the negative 4 or any number, like what that relatively means, expand it out. But yeah, sometimes the calculators like to keep it. It's easier to do scientific notation without a calculator. Yeah. It's kind of a pain to type in to a calculator. So yeah, for these ones, I wouldn't even be doing them in a calculator. I would just follow the system. So let's try it out. 8.26 times 10 to the negative 3. So the way that I'm going to start this is I'm going to go 8.26. I write the decimal. Now, is this telling me that I have a big or a small number? It's telling me I should have a small number. Again, some teachers say, oh, well, if it's negative, then you're going to hop it to the left. I don't do the left, right. I just think small number. Okay, negative means small. So I better hop 3 in the direction that's going to equate to a small number. If I start going to the right, my number is going to get bigger. We want it to be small. So 1, 2, 3 hops, put the decimal in, And then in these empty hops, I need to add zeros. Okay? So 0.00826 is the same thing as 8.26 times 10 to the negative 3. This one here, 5.01 times 10 to the 7th. So I'm going to write my decimal out. This 10 to the 7th means my number should be large. So I don't want to start hopping this way. I want to start hopping in the direction that expands the number to a larger number. So we're going to go 1, 2, 3, 4, 5, 6, 7. Okay. All of these empty humps need to get filled in with zeros. Okay, you can put some commas in there too if you want to give it some better magnitude. And what we can see here is we have what, 50,100,000. Oh, this one down here, isn't that fun? All right, so I'm going to write the 9.4 all the way over here. How many hops do I have to take in the small direction? 24 hops. So I know that one of the hops is going to take into account the 9, right? One hop here. So how many hops do I have left? I have 23 hops left. So that's 23 zeros. So I'm just going to fill in 1, 2, 3, 4, 5, 6, 7, 8, 9, come on, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 zeros. Again, 23 zeros, not 24 zeros, because one hop to get over that 9. Decimal there. That's a total pain to write. That would be a perfect example of when we want to, hold on one second. Sorry. That'd be a perfect example of when we want to write it in scientific notation. So any questions on scientific notation, expanding out, writing it in scientific notation? We're going to see lots of numbers throughout the semester in scientific notation. Okie dokie. So that is what we will cover for chapter 1. Let's get into chapter 2. Actually, I'm going to do this as a PowerPoint. Oh, come on, you're just going to take forever. My internet is not wanting to work right now. Just make sure they don't eat your homework. I love Great Danes. They're so cute. My husband and I are thinking about getting a Newfoundland, but I'm going to ride this semester out first and ride out having a 4-month-old and see how that goes. And then maybe we'll throw the Newfie in the mix. We have 2 other dogs. If you don't know what a Newfoundland is, they're large and in charge, for sure. All right, Moodle. Why you got to be this way to me? Oh, an Aussie puppy. Those are so cute. The problem with Australian Shepherds, though, is that they're so smart. They're like way smarter than I am, and they can definitely manipulate me. I need my dogs dumber than I am. So we stick with like French bulldogs and boxers and all the bully breeds. Because otherwise they will definitely control me. Okay, come on. Aw, babies. Moodle, you. I'll just log out. Go back in. Sorry, everyone. I don't know what's going on here. Let's see if we can get it here in the next minute or two. Otherwise, I'll just lecture, I guess, on the fly. Okay, I can't see any of my courses. I'm going to stop sharing for a second, my screen, and see if that helps. X out of here. So it's just thinking, doing its thing. So we'll give it a minute. One thing I did want to talk about is at the end of the semester, people will ask me if I offer extra credit, and I don't really offer extra credit as far as like assignments are concerned. I do offer one form of extra credit. And this is actually a really great year/semester for this extra credit. The extra credit, you will get 10 points of extra credit towards your lowest test grade. So let's say you got like a 60% on a test, it could jump to a 70%. What you need to do is vote in the 2020 election. Yay! Yeah, big election, okay? If you haven't noticed, it's flown around. There's some interesting characters out and about. So you don't have to tell me who you're voting for. I don't care. Well, I care who you're voting for, but I don't care, okay? So I just want you to vote. I just want you to be a participant of this really, really important thing. If you're not registered to vote, then you got to register to vote as well. It's not that hard to do. You can look online how to register to vote in North Carolina. The difficult thing is that you can't do it. You can't actually do the registration online. It'll give you directions on how to do it. Vote for Kanye. I mean, to each their own. So if you're not registered though, do a little research to try and make that happen. If you can't register, any functioning adult. Anyway, if you haven't registered and you can't figure it out, you can always email me directly and we can chit chat about it, how to do it. So how are you going to give me proof that you have voted? Well, you're going to go to the voting station. We're not going to get political here, everyone. We are going to be political. We're not going to get political. So, you know, when you go and vote and they give you like that little sticker and you take your picture and put it on Facebook or Instagram and you're like, look at me, I'm so political. Okay, you're gonna do that. And then you're also gonna email me a picture of that little sticker. All right, don't do it at the voting station because we're getting political. Don't do it at the voting station because they are not gonna like you taking a picture inside the voting station. So you gotta do it outside of your car, all right? If for some reason you can't vote, because I know that there may be people who are not citizens, who are not old enough, who have other things going on in their life that are not allowing them to vote, that is fine. You can still receive extra credit. The way that you're gonna do that, you have to do a little bit more research work. What I'd want you to do is look up the candidates for your district on a local level, on a state level, and then also on the national level. You probably know the national candidates. And so what I want you to do is give me a bullet point for each of their political stances. Okay. I wouldn't really want to do that. I would just go vote. All right. If you can vote, it's a super cool thing to do. It's like totally sexy 2020. So if you have any other questions on that, you can ask me, email me privately about it. All right. I think maybe Moodle is wanting to work for me. Oh, come on, baby. Let's do some chemistry. I'm seeing if this thing will open. Yeah, politics, exactly. It's a mess. It's a mess, but I don't want to get into the politics of it. I just want you guys to be practicing one of the best rights that we have as American citizens. There are a lot of countries where people don't get to freely vote. So make that happen. And there are places in the United States where it can be difficult to vote, even if you can vote. So if you're having difficulty with that too, you can talk to me about it. I don't know what's happening with lab. Can you mention what we're using Mastering Chemistry for? Mastering Chemistry is going to be for all of your homework assignments. 9th presidential vote. Awesome. Rockstar. Awesome. So Mastering Chemistry is where all your homework's going to be on the, whatever. Don't be bratty, guys. On the Moodle website, you can see, it'll say something like, where is it? Up here. So here's the Mastering Chemistry with the code. So that's just going to be where you'll do all your homeworks. It's separate from the labs. Yes, it is a separate entity from the labs. Computer is burning hot right now. I can hear it. It's like really working to open this file. Come on. You gotta give me a hard time. I gotta make sure these are open before next lecture so that this doesn't go on again. What can I do here? What can I do? There's an email on anything. No. Shoot. Okay, well, I'm gonna just sort of, I'm gonna lecture on the fly a little bit here on significant figures. And if that slide pops up, it pops up. If it doesn't, it doesn't, okay? How many attempts do we get with each question, and does it offer, wow, chat is hot today. Does it offer a similar question if you get it wrong? Yeah, if you get it wrong, it'll give you another opportunity to try it. Trouble with the volume measurement, yeah. So, in the lab, helpful hints and what labs we need to do. It asks us to do the lab safety test and tool test. If you want us to do the lab test, and if so, how do you want us to submit it? You don't have to do the safety test, because we're not doing like actual labs, so I'm okay with that. You guys can skip over that. Five tries. Hannah knows this. Each one gives you 5 tries. Not that Hannah's been to the 5th one, but she knows. Okay, so yeah, I don't know what's going on with Moodle. It's freezing up on me. So we're just gonna, we'll just go to our whiteboard here. We're gonna talk about significant figures. So I'll share my screen in just a second. Question about meeting on lab days. No. Lab times, which is Tuesday, Thursday, are your times to work on the labs independently. I'm available by email. And if you need to set up like not a Moodle, a Zoom meeting, we can set up a Zoom meeting and chit chat, and you can show me labs and stuff like that. So the lectures are synchronous, the labs are asynchronous. Okay, let me share my screen with you all. All right, so when we're talking about yes, there are certain things in the lab that I want you to skip. All of that information is in Moodle. So if you go to the lab section in your Moodle page, it's not going to show up for me here, but at the very top, it says all lab procedures and data. That will tell you what to skip and what not to skip, okay? So it gives you each lab step by step. Question. Poison ivy on both arms and legs. Oh, that's unfortunate. Let's leave the chat for questions on chemistry. And if you want to talk about your poison ivy afterwards, we can. So I'm going to write a number in a couple different ways, okay? Four. 4.0. 4.00, 4.000. So when looking at these numbers, they're all telling us that we have 4. Let's say that we're talking about pounds. Okay, it's pounds of sugar. In this first one, oh, thank you. You were too kind. Let's see if my computer will take it though. Let's see if that'll open up. See, it's just my computer is just going so slow. So for each of these numbers, we're talking about 4 pounds of sugar, but what's happening as I move down is we are getting more precise with our measurement, right? This one on top is saying, yeah, I don't know, I got like 4 pounds of sugar, right? They probably use like a bathroom scale to measure that. So it's not super precise. This number here, we're saying, no, it's not just that we have 4 pounds of sugar, we have 4.0 pounds of sugar. So we are precise to the 10th place. This is telling us that we have 4.00 or we're to the 100th place. And then this bottom one is like, oh man, we have like, I mean, we don't have exactly 4 pounds, but we've got really freaking close to 4 pounds. We've got 4.000 to the 1000th place. So each of these numbers is a little bit more precise than the number before it. Precision is something that we represent using significant figures. our significant figure tell us how precise something is, okay? So when we're classifying significant figures, there's a couple rules that we follow. The first rule that we follow with significant figures is that all non-zero numbers are significant. Okay, so we would classify all non-zero numbers as significant. Again, all non-zero numbers are significant. So if I write this number here, 3, 5, 2, 1. Every single one of those digits is significant. So this number we would say has 4 sig figs, okay, or 4 significant figures. Another rule is that, because it's easy when you have non-zero numbers, the zeros are what always give us trouble with significance, okay? The zeros are what throw us off. So if I write a number like this, 1, 0, 1, this number is significant and this number is significant. Any zero that's in between two significant numbers is also itself significant, or it's also representing some sort of precision. So you're never going to be like significant and then become not significant and then become significant again, right? You can't have like a number that's precise and then somehow in the middle it's not precise and then it's precise on the end side of it. So zeros in between two non-zero numbers are classified as significant. So I would say that this guy has 1, 2, 3 sig figs, 3 significant figures. Obviously, when we're measuring things in science, we want to have more significant figures, right? Because more significant figures tells us that our number is more precise. Another rule, so I'm going to write a number 35.00. Okay. The next rule says that zeros that come after a decimal place are significant. Zeros that come after the decimal place and after the trunk of the number or the main number itself. Those would be significant. So looking at this, the 3 is significant, the 5 is significant, and both of those zeros are significant. So we would say that this number has 4 significant figures. Scientists are lazy people, so they're never going to write 35.00 unless they have to include those zeros. Otherwise, they would just write 35. So when they're putting the zeros in on the end side, they're putting them in because that's how precise they are. They're saying, hey, the scale that I had was precise to the hundredths place. So if we go back up to the 4444 thing here, we can see that this first number has 1 significant figure because of the third rule we've been talking about. Zeros after the decimal, after the number are also significant. So this number would have 1, 2 significant figures. This guy would have 3 significant figures. This here would have 4 significant figures. Obviously, as we continue adding zeros, we'd be getting more precise. Now, you can't just add zeros because you want to add zeros. You're adding zeros because that's like the piece of equipment has given that to you. Another rule says that, hello, pen. Okay. So I'll write a number 180.00. So zeros that come after the number but before a defined decimal place are also going to be significant. Okay, again, zeros that come after the main number and are before an actually written decimal are significant. We would include those. Again, 1 and 8 are going to be significant because they're non-zero numbers. These zeros are significant because they're coming after the number and they're coming after the decimal. And remember, you can't be significant, not significant, significant. So the ones in the middle will also be significant. So this number here has 1, 2, 3, 4, 5, 6 significant figures. 6 figs. So with that being said, I'm going to write the same number in two slightly different ways. If I write 160 like this, and I write 160 like this. This first one has two significant figures. The 1 is significant, the 6 is significant. This 0, I don't really know if it's significant. That is sort of ambiguous. I'm not sure if I want to include that in the significance. So we would say that this thing has a minimum of 2 sig figs. This one down here doesn't have an inferred decimal. It has an actual decimal written in place. So in this case, the 1 is significant, the 6 is significant, and the 0 is also significant because the 0 comes after the beginning number before the decimal. So 3 sig figs. Again, what is this whole sig fig thing about? It's telling us how precise our number is. So when doing measurements, we want to have more sig figs. Another rule. So zeros that are in the front of the base number are not significant. Zeros that are in the front of the base number are not significant. They're only acting as a placeholder. Okay, so I'll give you an example. 0.00035. When looking at this number, the base number is here, right? This is significant and this is significant. All the zeros sitting in the front are just telling us how big or small the number is. So we would say that this has 2 sig figs. I'm going to do just a real simple conversion factor to sort of drive that last one home, that those zeros don't tell us anything about precision, because precision happens as we move out to the right of our number, not as we go to the left of our number. If I have a number like this, 0.068 kilometers. So let's say you went running and you ran 0.068 kilometers. That's not very far, but let's say that's what you were able to do for the morning. And you were trying to tell your roommate, you know, I went 0.068 kilometers, and they're like, I don't really know what that means. Like, I kind of know what a meter is. So can you reference it to that? So I'm going to convert this into meters, and just trust me on this. I'm going to move the decimal over 3 places. Okay. 1, 2, 3. So then you could tell your roommate that you ran 68 meters. That doesn't sound quite as dramatic as 0.068 kilometers. I ran part of a kilometer. Yeah, you ran 68 meters. That's like halfway down your block. But what we're seeing here, do I put this 0 in front? Wouldn't that look weird? Like putting that 0 right there? We don't put zeros in the front. So this isn't acting as any sort of precision. It's just a placeholder for the decimal. Okay, so that's why we don't include that. If I had written this number like this, 0.0680 kilometers, and I wanted to convert that into meters, I'd move the decimal over 1, 2, 3. It'd be 68.0 kilometers. I'd keep the 0 at the end. Why? Because that's telling us something about precision, how precise the number is. And then sort of piggybacking off of, where was it? That was precise, that was precise. I'll just give you one. Okay, if I write this number here, 6 billion. Okay. There is no decimal place written in. So the only number here that's significant is the 6. Zeros that come after your main number but are lying before an inferred decimal, meaning the decimal isn't written in, are not significant. They're considered ambiguous. So I don't know if those zeros are significant or not. I don't know. So I would have to go with 1 sig fig here. What if like this is significant and you know for a fact that this, and this are significant? Those zeros are significant because of what you used for your measurement. How can you get around this sort of problem with some of the zeros are significant and some of the zeros aren't significant? I would write this in scientific notation. The decimal lives here. I'm going to move it here. I would write 6.000, include the significant zeros, times 10 to the negative. No, we don't want it negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the 9th. Positive 9. Okay. So we could get the zeros embedded in there, and then I can see, oh, this thing has 4 sig figs. So those are the rules of significant figures. Does anybody have any specific questions about that before I'm gonna, well, I don't even know if I can throw out the worksheet because my computer is not doing its thing. Yeah, I won't be able to. I can give you guys a couple example problems. Does anyone have any questions though on the rules of significant figures? So all non-zero numbers, significant. Internal zeros between 2 non-zero numbers, significant. Zeros that come after a decimal place, after the main number, significant. Zeros that come before a number after the decimal place, not significant. Zeros that come after the main number, but before an implied decimal place, not significant. So it's the zeros that are always going to give us trouble with figuring out how precise or significant the number is. So let's try a couple. So I'm going to write some numbers out. I want you to tell me how many significant figures they have. Okay. All right, so for this first one, sort of want to take a peek and figure out like where the main number is. So here's the main number. This is significant, and obviously the 1 is significant. The 0 in between is also significant. And then these zeros here are not significant. They're in front of the base number after the decimal. They're just acting as placeholders to let you know how small or big the number is. This 0 over here, though, he is significant. He comes after the number, after the decimal place. He's letting us know about precision. So we've got 4 sig figs. This guy here, already I can tell that it's an ambiguous number, meaning that we aren't going to get a fully clear answer on how many sig figs there are. This is significant, this is significant, this is significant. I know that the 0 is significant because it's in between. These zeros, I have no idea. The way that it's written, I can't tell you. So if we were to run a calculation, we would only be able to honor 4 sig figs. Here, we've got significant. There's my decimal. It's drawn in. All these are coming after the main number, and there's a decimal. So significant, 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 significant. If the writer just wanted to write 200, they would just write 200, but they didn't write 200, they wrote 200.00 because this number is precise to the hundredths place. So here we've got 1, 2, 3, 4, 5. 5 sig figs. Okay, so any questions on significant figures? No? Okay. Cool. So we're going to stop there for today.
I was going to add, if you don't mind.
Yep.
This is my second time around with chemistry. I mean, it's been a long time since I was a student. For some reason, I totally understand what you just explained, whereas like 3 months ago, I had a problem with it. So I'm just glad that I guess I have some of the memory from the class before, because I totally get it now. So thanks.
Well, good, good. I'm glad that it's making sense, especially when we're kind of isolated in our houses, because it's like, I don't know if people are getting it. So let me know if you're getting it. Let me know if you're not getting it. I can try and help you out. So tomorrow is, there is a lab section from 11 to 12:15. Again, that is lab working on your own terms. So if you want to work on it at that point, because that's where it was scheduled and it makes sense with your schedule, then work on it there. I will be available, but we're not having a formal meeting, okay? Well, I'm glad that I was able to help make that clear for y'all. So yeah, that's all we got for the week. So check the syllabus, make sure you verify the syllabus, make sure you get into Mastering Chemistry. I will have the slides downloaded next time before we lecture so that we don't have to sit around and wait, because I don't like lecturing like this. I like having at least some slides. Otherwise, that's really it. So you guys are done. Have a really good weekend. And if you have any questions, feel free to stay around and I'll throw you in a weight room and then bring you in one at a time, okay? Otherwise, toodles. Bye.